Topic 6.4 Metal casting. The picture on your right hand side over here shows complicated parts. For example, the engine cases over here, the piston head, and a huge turbine that you can see the people are so small in comparison to the turbine itself. So the casting requirements are first when complicated shape is needed and where the large part is made. Casting is suitable for metal with low melting point and good flow ability or castability. And next, casting is suitable for metal having too high strength to be produced by metal forming, and when the strength and ductility are not critical. And finally, casting is required when large volume of production is made. All metal casting offer economical choice for metal processing. And within this topic, I'll be talking about three processes of metal casting. First is the sand casting. Second is the die casting, and last, investment casting. This diagram shows the flow chart of the casting process in detail. First, we start with pattern making. We start with making a drawing of that metallic part and then make it into the so-called pattern. The pattern can be made of wood or metal, depends on durability, and the wooden pattern is halved along the parting line. In the process, cold making may be needed if we want the hollow part like this, making like a tube. Next process is to prepare the molding sand or the green sand that is composed of sand, bentonite clay, and pulverized coal and water. The molding sand is also known as foundation sand. And when the pattern and the molding sand is ready, we go into the next step of mold making. That for two half mold, we make the bottom mold first when facing half of the pattern down and filled up with the molding sand. Then do the same thing to make the top mold and put them together. And after that, take the pattern out and then put in the sand core that have previously prepared. And once the sand mold is ready, the raw metal that has been melted in the furnace, and then once ready, pouring into the mold cavity. After going through solidification and cooling, the metal part is strong enough to be removed from the sand mold. Then we go into cleaning and inspection, that we have to cut off the metal piece from the gating system and going through inspection for the finished casting. For sand casting, it is a metal casting process that characterized by using sand as the molding materials. And for the sand mold, you can see all the details in this picture. To make the sand mold like this, you have to know what are these components of sand molds made for before we start pouring the molten metal into the sand mold. First is the flask that you can see from the blue parts over here. The flask having the top and the bottom. And to make the top mold, it is called cold. And for the bottom part of the mold, it is called drag. Filling inside the cup and the drag is the molding sand that has been well prepared. And the top part of the mold and the bottom part of the mold are sectioned through the parting line over here that we can open the mold very easily after the part solidifies. Inside here, as you can see in green, is the mold cavity. That is the empty space that has been previously occupied by the pattern, resembling the metallic part to be produced but in a bigger size. Next is the core that is made from sand. The core is used to replace the empty space that we don't want to be filled with molten metal. In other words, it is for making the hollow part. Next are other empty spaces that are not part of the casting or the product. First we start over here is the pouring basin, where the molten metal is poured through the sprue down here to the gate, then the choke and the runner before going through the mold cavity. Along the way there is blind riser that is to feed the molten metal into the mold cavity. And also, once the mold cavity is filled, the molten metal is rising up through the open riser over here. And the molten metal in the open riser help feed in the mold cavity during solidification to compensate for metal shrinkage. Another opening here is called vent. and that is to allow the gaseous substance to flow out so that it is not trapped within the mold cavity to produce porosity that is not wanted as good quality castings. And once the molten metal in this mold cavity solidifies, the cope and the drag are parted, so we can take the solidified metal castings out to be cleaned and inspected for the finishing part. I'll bring you back to the first step. Being seen here is the casting that is smaller than the pattern, as you can see from the right hand side. And this is to compensate for metal shrinkage during solidifying from the liquidous phase down to solid phase and during cooling. Different metal alloys have different solidifying shrinkage, so we have to be certain about solidifying shrinkage that we used to make the pattern for each metal casting. So the picture on your right hand side showing the pattern that have been halved. Therefore, this dotted line is the parting line showing the top half and the bottom half. So the top half of the pattern will go to the cope or the top mold, and the bottom half of the pattern will go into the drag or the bottom mold. After that, we have to consider the gating system or the path that we will pour the molten metal into the cavity. First, here is the sprue and the runner that attach next to the pattern, and here is also the riser here and there to allow excess molten metal to feed back into the mold cavity upon solidification. In the next step of sand mold making, remember that we have to make the bottom mold first. Here we put the flask onto the base and then facing the bottom half of the pattern onto the base. Then we have to sieve the sand through the riddle, and this is called facing sand. Facing sand needs to be cleaned and fine because it determines the final surface finish of the metal casting. Next, we add up more sand onto the top till the flask is completely filled. The next step is to level the sand on the top surface by using the ram. The ram is pressed from outside towards inside of the sand mold in order to make the molding sand denser and stronger. Then roll over or turn up the flask so that the bottom half of the pattern is facing up along the parting line. It is time to assemble the other half. Once put on the upper flask, the upper half of the pattern is facing down, located by the pin. Then attach the sprue and the risers on the location that most suitable. The sprue is attached onto the location that the metal flow path allows the shortest time to fill the mold cavity without turbulent flow. And here for the risers, it should be placed onto the location that can feed the molten metal into the mold cavity to compensate for solidifying shrinkage. Such locations are thicker parts or where the last liquid metal will be solidified. Next step, we put the sand over on the top again and repeat previous steps till completed. After ramming on the top surface, then to level off the top surface. Then in the next step, detach the cope and the drag so that we have each half of the pattern facing up, as you can see from picture on the left and the right hand side. Next, it's time to extract the patterns upward. And this time you have to be very careful that you don't break open the sand mold that we have previously made. The trick is to get the patterns out very easily. Before we put the facing sand, we normally apply the graphite onto the surface of the pattern, and the graphite powder will act as the solid lubricant that prevents the pattern surface stick onto the facing sand. According to the part to be produced, we have to insert the core that make the hollow or the empty space in the sand mold. To that, we need the core box that we put the sand inside. The sand cores are commonly molded from a mixture of silica sand grains and a resin binder for coating and binding the silica sand grains. After making the core sand, take it out and then place it into the location that wanted to be hollow, right here as you can see from the picture. Then facing down the curve onto the top of the drag as you can see over here. And now we are ready for casting of the molten metal. And before pouring the liquid melt into the sand mold, you have to make sure that have enough pressure to put onto the curve. Otherwise, the pressure built up inside will lift up the curve, and then the molten metal will get through the parting line and split out. Once the melt is ready, pouring onto the basin, get through the sprue runner and getting into the mold cavity. Some of the melts rise up into the riser. And then during solidification, this melt will feed in to compensate for solidifying shrinkage. As you can see from this picture, the liquid melt is solidified in the cavity and shrinkage already taken place. Once the casting is strong enough, shaking out from the sand mold to take the whole part out. So here you can see the casting still attached to the sprue and the risers. Next, we have to trim all these parts out. So, at the end, we obtain the casting, and all the parts that have been trimmed out will go for the remelting as the scrap. Moreover, the sand is reusable after cleaning. So after all, the sand casting process is still economical based on the raw materials used and the process investment. And finally, the casting yield can be obtained by having the weight of the casting divided by the total weight of the whole casting and the scrap. Therefore, for good melting, we would like to obtain high casting yield so that we don't lose too much of the scrap during the process, although it can be remelted. And this slide shows some pictures of the metal casting or the foundry laboratory that we handled in the School of Metallurgical Engineering at SUT. As you can see, melting of metal concerns high temperatures, so we have to wear the safety suit that can withstand high temperature, and also the face shield that can protect our eyes from seeing the molten metal. And for casting of cast iron, the melting temperature can be high up to 1450 Celsius. So when pouring, we have to be careful, and also everybody who works together in the foundry. The next metal casting process that I'll be talking about is the die casting process. The die casting process is good for small castings and using hydraulic forces to fill the cavity. And within the process, we use the metal dies instead of sand mold, and hence the name die casting. And for the metals that are suitable for die casting, they are having low melting point such as aluminium, magnesium, and zinc. It is therefore economically for high production volume. The pictures above here showing various engineering parts produced by die casting process. And the die casting process can be classified as the low, medium, and high pressure die casting. This is according to the pressure applied during casting. If you notice picture on your right hand side over here showing the example of hot chamber die casting machine. As you can see, the machine consists of three main parts. First is the clamping unit over here that clamping on the die assembly. And next here to the right is the injection unit where the metal over here is melted in the furnace. And within the hot chamber over here, a shot of molten metal is purged and then going through the die cavity and solidified as casting over here. So for the die casting process, the liquid melt is purged into the die cavity either by ram or piston, gas or a pump, and either by means of high or low pressure. The picture on your left hand side here showing the diagram of low pressure die casting. As you can see over here is the crucible where the metal is melted while feeding from the top over here, and by applying the pressurized gas into the chamber, the molten metal will go up through the stalk and to fill in the die cavity over here. The upper die and the lower die are attached by the platen. Once the metal solidified in the die cavity, the moving platen moves up and then to allow the metal piece to be ejected. So for low pressure die casting, the liquid metal enters die at relatively low velocity. And it is different from the high pressure die casting, while high pressure involved in the casting process. As you can see from the schematic diagram over here, that both halves of the die are attached or clamped by the moving platen and the fixed platen. The short sleeve of the molten metal is poured inside, allowing the piston to press the molten metal feed through the gate into the die cavity. Once solidified, producing the casting that is then ejected after the moving platen moves to the left-hand side. Then the ejector pins will push out the casting for finishing and inspection. Therefore, for high-pressure die casting, the liquid metal enters die at very high velocity. Therefore, normally no sand cores are used. And for the high-pressure die casting, it is normally applied for making thin ball parts and small castings. The last type of metal casting is the investment casting process. In the process, the small parts with complex geometries and intricate details such as jewelry, high-value components are made, such as titanium casting, as you can see from this picture. Over here is the investment casting of jewelries of gold and silver, and these parts are very small that have to be stacked onto the main core. And onto the left-hand side is the titanium casting. Within the process, the melt is poured into an expandable ceramic mold formed by using a wax pattern, as described by this picture. First, we need to make the pattern 3 that made from wax. The wax patterns are attached onto the wax gating system with the liner and the sprue. After that, making the ceramic shell mold by dipping it to the ceramic thoroughly that will make the coating onto the wax pattern surface. And then before we pouring the molten metal inside, we need to get rid of the wax pattern by putting it into the oven in order to melt out the wax at low temperature. Depends on the type of wax that we're using to make the patterns. And after the hollow ceramic shell mold are ready, then pouring the molten metal into the mold. Once the metal inside solidifies, then we can break open the ceramic shell very easily. And the ceramic shell can be ground and mixed as the ceramic slurry used in the previous process. So finally, we will obtain the metal product trees as you can see in this picture. They have to go through the finishing and inspection process before going to the customers.